Hi, welcome back to RISC-V instruction encoding. We have seen R formats and I formats so far, and we have seen that load instructions fit nicely into the I format. Can we fit store instructions into an existing format? Unfortunately not. We need a special format for the stores because they use registers differently. Remember how the stores work. We have two source registers. One stores the data, one register stores the data they would like to store in the memory, the other one stores the base pointer to the memory. Then we also need an immediate value that we are going to add to that base pointer to form the address where we would like to write. So this is different than what we have had before. We need two of our source registers like we had in the R format, but we don't need a destination register because we don't write anything into our registers. We write into the memory. So our instruction format needs to have space for the opcode, RS1 and RS2, and the immediate value and the func3 field to support different kinds of stores. But what is important to notice is that we always want to keep the locations of registers in the same place in our instruction, because those are important. We don't want processor to be looking for registers all over the place. Where are they? Where are they? It's like in Gradescope where when we have to put exactly where to look for the answers when they're written answers to the test. So these locations, the fields where the registers are, never move. We do move, however, the field where the immediate values are. So in this case, the immediate is split in between the upper 7 bits and the 5 bits where the RD used to be. So it is still a 12-bit immediate, except that it consists of 7 upper bits and 5 lower bits. Again, this is important. It looks confusing to us, but we are not the ones that are important. Processor is important. Processor needs to find where are its registers very quickly. Let's take a look at an example of a store. So here is an instruction to store a word from register x14 into a memory location that is pointed by the base register x4 and an offset of 8 that is stored as an immediate value. So we get a new opcode for stores. This is 010011. That's a store. And we have a source register. RS1 is 2. That's our base. RS2 is our content. And then we need to form our immediate. We need to form our offset out of two parts of the immediate. The lower 5 bits are here. They're going to contain a value of 8. The upper 7 bits are in the topmost 7 bits of the instruction. When we put them together, we get our combined 12-bit offset that in this case is +8. And that's it. That's an illustrative example of how does the store work. There are 3 types of stores that RISC-V supports. We can store bytes, we can store half words, and we can store words. Once again, bytes are 8 bits wide, half words are 16 bits wide, and words are 32 bits wide. And that is it for the S type. We'll make a break here. You may want to take a few minutes longer break, and we'll return with a few more formats. See you there.